All right, ladies and gentlemen, so I wanted to kind of go through one of each of the types of problems that we've seen. We've learned it all now that we learned the quadratic formula yesterday. And here's some things that you might see as you bump into these. So one of the first things is, hey, look at this problem. I see 1, 2, 3 terms here, which means maybe I can factor it. If you can factor it, that's sometimes the easiest way. Remember, you can use the quadratic formula all the time. So if you want to use the quadratic formula here, you could. And you could jump straight into there. But hey, I think if I did 2 times negative 21, we got negative 42. I could find things that multiply together to be negative 42 that add together to 11. And we could go through that whole process. And I believe there actually is those factors. I believe if I do 3 and 14, I could get those. If I had a positive 14 and a negative 3, these would do these. So I'm assuming you can find your factors on your own there, but you should be able to factor this. And if we do, remember, because there's a leading one, or because there's a leading 2 here to start, I had to do 2 times negative 21, and then I'll have to break out in the middle. If I just had a 1 in front, even better. We'd already be done almost. We do need to get these, so we'll break this guy out. This will say 14x minus 3x minus 21. And the other stuff kind of just comes down. 2x squared. The minus 21 comes down equals 0. So if I factor by grouping, you're good at this by now. What can I take out of these? 2 and always an x. If I divide by 2 and steal an x, what happens? Well, I get x plus 7. And hopefully if I do it right here, what do I have to break out of this chunk? Well, a negative 3. Make sure because this is negative, I do take out a negative 3. If I divide each of those by negative 3, I get x plus 7, and that's great news because my middle things match. So my front stuff, 2x minus 3, and my inside stuff. So that was all factoring. That was stuff that we did last unit. We tested on it. You guys were good at it. But we're not just done there because this is a whole new unit. And what we're actually trying to do now is use this to solve. So I have to say, hey, set this equal to 0. 2x minus 3 equals 0. And I need to solve this. Well, solving this should be pretty straightforward. It's a 2-step equation. We learned like this stuff day or week 1, week 2 of math class. If we add 3 to both sides, we get rid of it that way. 2x equals 3. And then if I divide by 2, x equals 3. Great, we nailed that. Okay, and that's one of our answers, but it's not my only answer. We still need to go back and say, hey, what about this one? X plus 7 equals 0. So if I subtract here, these together are my final answer. If you want to write them nice and neat, one of them together, you can say negative 7 and 3/2. Those are my 2 solutions there. Boom. We should be expecting essentially get 2 solutions for all these 2. So that's just if you can factor. This was kind of a long one to factor. Sometimes they're even shorter to factor if you don't have that leading one or that kind of thing. There are also 2 other cases. Hey, what if I only have 2 chunks? Well, if you only have 2 chunks, fine. Okay. In this first one, there's x's in both of these, so we're actually going to use factoring to do these. So if there's 2 chunks and there's an x in each of them, you should be thinking, hey, maybe there's a GCF I can take out of there, including a variable. In this case, there is. I can take out 2x that are each divisible by 2, and they both have x's, which means I can steal an x from each of these. If I do, 4 divided by 2 is 2, and x, stolen x, I had x squared, a stolen x, and I'm left with 2x. Cool. And then a positive 6 divided by 2 is a positive 3. I had an x, but I stole it out front, so that one doesn't have it. So this is actually kind of nice because this goes quick. Now I really have 2 chunks, kind of, right? I can kind of pretend there's parentheses around here. We don't need them because it's all just one chunk in the front. But either 2x equals 0, which isn't terribly exciting because if I divide by 2, that just means, well, x had to be equal to 0, which is one of my solutions. Or this guy, 2x plus 3 equals 0. You can tell I use a lot of my same factors when I'm making these problems. But if I subtract 3 here, divide by 2. Boom. These are my two answers. You could once again rewrite them in a little neater if you want, but those are my two answers for these. So anytime you have two chunks, you should be looking for a GCF. In this case, I could take a variable out of each, which made my problem a lot easier. And then each of those little chunks we set equal to 0 and solve them. The other thing that can happen can look like that second one over there. The second one over there, if you look at it, I'm just going to do this. You're more likely to see something like this. So if you see something like this, like, hey, there are two chunks here, okay? But in this case, I don't have an x in both of them, so I'm not going to be able to peel that x out front. This guy that I did here, he was there because I had an x here and an x here, and I don't have that in both of these. So if I look on the right, what I can do is I can solve by square roots. So this is kind of a whole different solving. We're going to get that x squared by itself. And then I get to take the square root of both sides. Sometimes I'd have a number in front of my x squared there, and I'd divide it, but I don't in this case. Sometimes you would. If I took the square root here now, I get x plus or minus. Well, the square root of 25 is 5. Great. Very cool. Now, remember, if you had, like, let's say the square root of 40 there, the square root of 40 isn't terribly nice, and you need to break it down. You would say, if I had x squared, so this is done. But in a what if situation, if you had, let's say this said x squared equals 40, after all that, you would, when you take the square root, need to break 40 down and say, well, this is 2 times 20 and 2 times 10 and 2 times 5. So the leftovers being 2 and 5 for so if it's a nice square root and is perfect, just tell me plus or minus something like 5 or something like 7. And if it's not perfect, you might have to do some reducing, which we're going to do in the next problem as well. Okay. So then the last thing that's on here, the last type of problem that you'll see is a 3-termer that can't be factored. So I can't factor this. If I did 3 times -5, there's nothing that multiplies together to be -15 that adds together to be 8. It just isn't anything. You could try and there's no values that would do it. We can't do it. So if I get rid of here, I need to change this to 7. Just trust me. Okay. So this one, and once again, it still wouldn't work with the 7 either. So if I went and did this, then we have to use the quadratic formula. If you don't have the quadratic formula written down, it is x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we need to do this. We'll grab what a, b, and c is, and we'll just plug it in and let the calculator do a lot of the work. So if I do this, my a value here is 3. My b value, 7. And my c value, -5. We just grab from each of those. It goes in order. Whatever's with x squared is my a. Whatever's with my x is my b. Whatever's by itself at the end is -5. In this case is my c value. So we'll go through and do it. It'll say x equals -b. Currently I have a +7 here, so I'm going to say -7. If it was -7, I'd make it a +7. So we're just switching sides. Plus or minus the square root of b squared minus 4 times a, which was 3 in this case, which times c, which is -5, all over 2 times a. 2 times a, which is cool. So go through and let your calculator do this once again. Your best bet is to type in all the stuff underneath the square root without the square root sign. So just the stuff inside here without this. if you just type in 7 squared, let's try it. 7 squared minus 4 times a, which was 3 times c. Oops. Let's try that again. 7 squared minus 4 times 3 times -5. What do you get? I got 109. Over 6. 2 times 3 is 6, so you can multiply that bottom down there too. So, and actually, we get to be done with this whole problem right here. I'd try and break down 109, but 109 does not seem to have any factors at all that go into it. There's nothing that divides into 109. 109 seems to be prime, which is great news for us, honestly. It just makes our life easier. So this is going to be the end of our problem. That's great. If it was like the square root of, let's say, 64, that would break down into 8, which would be nice, and we can actually get down to some final answers. But if the square root is nasty, you just kind of get to be done there. Wild. We did some different ones in class yesterday, so I'll post that recording as well. But if you get to the square root and you type in the square root, if your calculator is kind of nasty and there's no factors of it, you'll actually leave it like that. So that is kind of all the ways we learn to solve, which should get you pretty well prepared for your test coming up this Friday. Let me know if you have questions on any